Welcome. This is lesson 3-4, writing proofs. By the end of this lesson, you should be able to explore and create viable arguments. So let's get started with some postulates. These are the ones we began the school year with off, and I began began with this school year on postulates, points, lines, and planes. So as a reminder, through any 2 points, there is exactly one line. Through any three non-collinear points, there is exactly one plane. A line contains at least 2 points. A plane contains at least three non-collinear points. If 2 points lie in a plane, then the entire line containing those points lies in that plane. If two lines intersect, then their intersection is exactly 1 point. If two planes intersect, their intersection is a line. Let's look at example 2. It says determine whether each statement is sometimes, always, or never true. Justify your argument. The intersection of three planes is a line. We just said the intersection of two planes is a line. The intersection of a third plane could also be a line, but it could also be a point. So this is sometimes true. The line R contains only point P. Well, between any 2 points there exists exactly one line, and then a line must contain at least 2 points. So it could not contain one. So this is never true. Through points H and K, there is exactly one line. Well, through any 2 points, there is exactly one line. So this one is always true. Take a minute, pause your video, and you're going to do example 2 check. Okay, determine whether the statement is sometimes, always, or never true. Justify your argument. Two intersecting lines determine a plane. Well, this case is never true. Two intersecting lines do not determine a plane. 3 points determine a plane. Now, we're going to learn about two-column proofs. Now, we're learning about proofs, period. We're going to talk about writing three different types of proofs. The first one's two-column proof, the next one's a flow proof, and the third one will be a paragraph proof. Now recall that Euclidean geometry is based on logical reasoning. A proof is a logical argument in which each statement is supported by a statement that is accepted as true. These supporting statements can include undefined terms, definitions, postulates, and theorems. A two-column proof is a proof that contains statements and reasons that are organized in a two-column format. You can develop a deductive argument to prove a statement by building a logical chain of statements and reasons. So, how do we write a proof? Here are 4 ways in which you can get started, or 4 ways in which you can do it, 4 steps to get it done. List the given information and draw a diagram if needed. Create a deductive argument that links the given information to the statement that you are proving. Justify each statement with a reason. Reasons includes definitions, postulates, theorems, and algebraic properties. We've already started looking at definitions and postulates. We're going to have our first theorem, and then we're going to look at some more algebraic properties. State what it is that you have proven. So, what are you doing? Listing the given information and drawing a diagram. Create a deductive argument that links the given information to the statement that you're proving. Justify each statement with a reason and state what it is you have proven. Here are a few properties, algebraic properties that you've learned in the past. So just a refresh. Reflexive, x equals x. So you'll see that when you're saying something is congruent to itself. Symmetric property, if x equals y, then y equals x. The transitive property, if x equals y and y equals z, then x is equal to z. The addition property and subtraction property allow you to add the same item on both sides of the equal sign. So you end up with x plus z equals y plus z if x equals y. Multiplication and division property allow you to multiply and divide the same item to each side of an equation. So in the addition, subtraction, multiplication, and division properties of equality, you're doing the same thing to each side of the equation. In your substitution property, which we've used earlier this year, if x equals y and x equals z, then y equals z. We replaced x with y because those were equivalent. Now, the first theorem we're going to learn about is the midpoint theorem. If M is the midpoint of line segment AB, then line segment AM is congruent to line segment MB. Let's try a two-column proof. So here's our example. Given that Q is the midpoint of PR, prove that line segment PR is congruent to line segment QR. 90% of the time, your first statement is going to be the given. See, it says Q is the midpoint of PR. Q is the midpoint of PR. That is given. The reason is given. So what do we know if they are, if they are, if their Q is the midpoint? What we learned earlier from the definition of a midpoint is that PQ is congruent to QR, or their lengths are equal. So PQ is equal to QR, and that's by the definition of a midpoint. We defined a midpoint, and it said that the two lengths would be equal. Now, notice in this box here, I've given you some possible answers. And when you're being assessed on this, they'll almost always give you that. I can't guarantee you on the quiz because I need you to know that information. So without the multiple choice. And so how can we go from PQ equals QR to line segment PQ is congruent to line segment QR? Well, that's the definition of congruence. If two items are equal in length, then the segments are congruent. Now, once a conjecture has been proven true, it can be used as a reason in other proofs. The conjecture proven above is known as the midpoint theorem. So we've proven that we can go straight from 1 to 3. That is the midpoint theorem. So I can, next time Q is the midpoint of PR, say that PQ, line segment PQ, is congruent to line segment QR, and I would be able to say by the midpoint theorem. Now, you have an example 3 here. That's your check. I know this clicks and says the same thing. I need to fix it. You're on the example 3 check. Go ahead, pause the video. Try this one on your own. Use the box down below that has some possible answers here. Okay. It says given B is the midpoint of AC and C is the midpoint of DE, and AB equals CE. So they've given you 3 statements. They want you to prove that BC is equal to DC. So we're only filling in the missing information. Here it is again. B is the midpoint of AC. C is the midpoint of DE. That is given. That's what's written here. Next, number 2. It's blank, but we know the reason is a definition of a midpoint. Now, by definition of a midpoint, we can only say the two lengths are equal. So, what are we saying are equal? If B is the midpoint of AC, then AB is equal to BC. And if C is the midpoint of DE, then DC is equal to CE. That's what happens by definition of a midpoint. Do you see our third statement on the given is at number 3? AB equals CE. That is given. So where can we go from here? We're trying to get to BC equals DC. Well, I should be able to do some substitution here. If AB is equal to CE, I now know that BC is equal to CE by the substitution property. And so that would give me my BC. And what would be the reason there? We just said it. It was substitution. So we write substitution property of equality. If you just write substitution, I would accept the answer. So what allowed us to go from BC to CE? we substituted CE with DC, if you see here, and that was the substitution property of equality. So you've completed example 3 check. Let's move forward. Now we're going to look at a flow proof or a flow chart proof. It uses boxes and arrows to show the logical progression of an argument. The statement is in the box and the reason is below it. Arrows indicate the order of the steps. So it says, example 4, write the statement and reason in each box to complete the flow proof. P is the midpoint of line segment JK. Guys, I realize that the diagram is not listed here, um, but you have it on your paper. It says P is the midpoint of JK. Well, how do we go from this given to a statement? Well, what can we say? We can use the midpoint theorem, right? Because line segment JP is congruent to line segment PK by the midpoint theorem. Now we've used the midpoint theorem, we can say that JP is equal to PK by the definition of congruence. At this point, we're substituting the values known from the diagram to say what parts are congruent. Well, JP is equal to X and PK is equal to 5X minus 8. That is through substitution, because we just substituted JP with its value and PK with its expression. So the next step after here, and we're solving for X, so what do we need to do? We need to isolate the variable. So we're going to move the variables to one side of the equation and the constants to the other. We do so by subtracting 5x from each side. If you see, we started with x here. Now we have x minus 5x and then 5x minus 5x. That was the subtraction property of equality. From there, we simplified or used substitution. X minus 5x is the same as writing negative 4x, and 5x minus 5x cancels, and that leaves us with negative 8. So we substituted this side of the equation with its equivalent value, which is negative 8. The next step was to divide each side by negative 4 using the division property of equality, and the result is x equals 2 by substitution. All right. I've done one flow proof. You try the next one. So pause the video and try it on your own. Okay, you were given FG equals HK. Prove that X equals 7. So we have FG equals HK. And what's the first thing they told us to do is substitute, where we're going to plug in those known values into the equation. So that's 4x minus 6 equals 22. And from there, we're solving for x, so we have to isolate the variable. Here, instead of subtracting 6, I'm going to add 6 to each side. And that is the addition property of equality. Once I substitute the values or simplify, you end up with 4x equals 28. And now we need to isolate the variables, so we're going to divide each side by x through the division property of equality, leaving us with x equals 7 by substitution. Good job. Last one, paragraph proofs. Another way to prove a conjecture is to write a paragraph proof that explains why the conjecture for a given situation is true. This is called a paragraph proof. A paragraph proof includes the undefined terms, theorems, definitions, or postulates that support each statement. So you're given that C is between A and B and that line segment AC is congruent to line segment CB. Write a paragraph proof to show that C is the midpoint of AB. So we're going to use 3 steps. We write the given and proved statements. Then we draw a diagram and label any given information, and then we write the proof. You're given C is between A and B and that line segment AC is congruent to line segment CB. Prove that C is the midpoint of line segment AB. Well, let's draw a diagram. Here I have C at the center and of AB, and I have A line segment AC congruent to line segment CB. So let's go ahead and write the proof. If C is between A and B, then by the definition of betweenness, A, B, and C are collinear, and AC plus CB equals AB. If line segment AC is congruent to line segment CB, then by the definition of congruence, the segments have the same measure, which means that AC is equal to CB. From the definition of midpoint of a segment, if C is between points A and B and AC equals CB, then C is the midpoint of line segment AB. Not so bad, right? But you do need practice. You try the check here. You're going to read through it and you're just going to fill in a blank. When they give you a paragraph proof, 9 times out of 10, this is the way they'll give it to you. You'll have to fill in the missing pieces of information. I've included your properties of equality on this page so you don't have to go back and look. So pause the video, take a moment, and try the problem. Okay, given that y is the midpoint of line segment xz and line segment xy is congruent to line segment wy, fill in the blanks of the paragraph proof to show that line segment wy is congruent to line segment yz. So what is our given? That's the first step. Y is the midpoint of line segment xz and line segment xy is congruent to line segment wy. They want you to prove that line segment WY is congruent to line segment YZ. So because Y is the midpoint of line segment XZ, then line segment XY is congruent to line segment YZ by the midpoint theorem. Remember, the midpoint theorem allows us to go from saying it's the midpoint to saying the two line segments are congruent. Next, we have the statement line segment XY is congruent to line segment WY. That was given. So by the definition of congruence, we can say that XY is equal to WY. So if we looked at that, we went from congruent to equal. That's the definition of congruence. And XY equals YZ. Right? We took these two statements that were both given as congruent to write them as equal. So XY equals WY and XY equals YZ. So now by the symmetric property of equality, we can say XY is equal to WY can be written as WY equals XY. What did we do? We switched the order in which we stated it. So by, let's say, the blank property of equality, WY equals YZ, what allowed us to say WY equals YZ? Oh, because we said XY equals WY, then WY equals XY, and we said XY equals YZ. So look, WY equals XY, XY equals YZ. So now by the transitive property, we can say that WY equals YZ. And then how do we say that line segment WY is congruent to line segment YZ? If we go from saying they're equal to they're congruent, that is the definition of congruence. Good job. So you have a mini assessment. You should try this one on your own. I'm not going to go over the answers. We will in class next time. And there will be a 3-4 writing proofs assignment. Thank you.